This right here is a 48 volt, 100 amp power wall. From EFG-Battery. EFG stands for Energy Future Green. So let's go ahead and unpack it and see what we got. First of all, as soon as you open it, you see that here is the giant bracket that you use to mount it to the wall. And we'll mess with this in a little bit. Some nice sturdy foam pieces so this battery won't move around at all. It comes with all the lag bolts that you're going to be putting in to secure it to your wall. And here looks like 4 terminal connectors with lock washers and washers. We also have a user manual, an inspection report, and accessories. All right, here's the user manual, so let me tell you a little bit about this battery. Okay, the model of the battery that I have right here is the EFG W48100. This is the wide version. There's also a wall mountable version that they sell. It's actually called the WL, and it's a little bit longer. The dimensions of this battery, it is 21.6 inches wide. It's 16.5 inches tall, and it is 6.1 inches deep. It weighs about 106 pounds, so that's 48 kilograms. In the manual, it says that this thing is designed to last 20 years. And it also has a 10-year warranty, so that's amazing. It has 4,000 cycles down to 80%, so you'll get 4,000 cycles from full to 100% to 0 to 100%. You'll get that 4,000 times before the batteries degrade down to 80%. Oh, and I forgot to mention that EFG, they also sell rack mountable batteries. The operating or nominal voltage of this battery is 51.2. The max charging voltage is 57.6. The cutoff discharge voltage is 43.2. The maximum charge and discharge current is 100 amps. All right, let's try to get this plastic off a little bit. Nice clean design. Has a front screen right here. It has a series of buttons. It has 4 lights for state of charge. It has an alarm button, and it also has a run button to let us know that it's on. Then it has actual 4 hard buttons right here for menu, enter, down, and escape. Let's see, I also see that it has 2 handles on the bottom where you can pick it up. Let's see if we can lift it up a little bit. There we go. Okay, it looks on the bottom. It looks like we have 2 positive terminals, and you can just pop these off. And here's your connectors right here. That's nice. There's nice covers, and they just clip right back on. And then there's also 2 negatives over here of the same design. There's also a DC circuit breaker rated for 125 amps. There is an on-off light right here. It looks like there's a reset button. The ADS, this is if you have multiple units. These are the dip switches that you'll be changing in order for all of them to communicate with one another. There's also the DCT, which is the display connection address. No, that's not it. Oh, it says it's a dry contact terminal. So I really don't know what that is. So if you know what that is, please leave it in the comments. We also have an RS-485 port, a CAN port, an RS-232 port. That's probably how we will connect it to a computer. And then we have 2 more RS-485 ports. I'm guessing that is the communication if you have more than one of these units. That way all the batteries communicate with one another. And then here are our handles, and we have this nice metal power button right here. And then on the bottom, here is this nice solid bracket that is welded directly to the case. And let's see how this thing fits on. And this thing, so it would go just like this and slide in. I mean, it's upside down right now, but you would lift it up, you would press it on there, and it would just slide into place. So very easy once you get this bolted to the wall. But everything is nice, sturdy metal. Unfortunately, this is really all I can do with this battery because I don't want to do anything else on the floor down here. But I can't lift it up onto my desk. Like I said, it weighs over 100 pounds, and I'm not about to like snap my back trying to lift this thing up. So what I did is I bought a hoist. And I'm going to install it. It's supposed to arrive tomorrow, and I'm gonna set up the hoist. I'm gonna hoist it onto my desk so we can continue on with this review. So I'll see you tomorrow. Actually, I'm not leaving quite yet because I wanted to tell you about this battery inspection report. This is pretty neat because it tells you what the inspection results were of the battery before they shipped it to me, and which I'm happy to see. All these say pass. I mean, can you imagine if they ship me a battery and this is like fail, fail, fail? God, I'd be like, oh, turn off the camera, goodbye. The one thing that I really care about is the factory capacity. They tested it at 103.8 amp hours of capacity. So this is my first 48 volt battery. So we're going to be kind of figuring out how to do a capacity test on this. I did get something that will run at 48 volts, and I'll let you know in another video because this is going to be a multi-part video because I'm excited about this, and I don't want to skip anything. But on this inspection report, it says what the factory voltage is. It shows what the factory state of charge was. It's between 50 and 60%. So it says it's at 56.61%. Like I said, 103.8 amp hours. I mean, you probably can't see this sheet. I'm sorry. But the width, the height, the appearance, there's no scratches, dents, anything like that. It says the LCD functionality, that it can show the relative parameters normally on there, and it does. You can disconnect the battery output. Yes, you can. Can use battery software monitor and the information of battery. You can do that through RS485, RS232, and the CAN port, and all those are checked. And then items packaged with product, terminal screws, rack, and expansion bolt. So all of those passed, and all of those are in here. So this is actually good to have, because if you got this and it says that it's passed, and then you get your battery and there's a giant scratch across it, you can email them and take a picture of this sheet and then take a picture of your battery and say, hey, you guys lied to me. I want a refund. So this is really good. I'm back, and we are going to check out this menu. So first I'm going to turn on this power button, and there is the welcome screen right there. So welcome to the Smart BMS. Press menu key, okay? Press menu. All right. And it says we got analog info, BMS status, parameter settings, and system settings. So let's press the top one. It says that the pack voltage is 52.79 volts. There's 0 amps because it's not plugged into anything. We can see the temperature. Here's the temperature of all the individual cells. Here is the environment temperature and the PCB, the system board temperature. Oh, and I said this is the temperature of all the cells. This is the temperature of all the sensors that are inside right now. All right, let's escape, go back. Let's go down. Cell voltages. You can look at the voltages of each cell in millivolts. 3299 millivolts for the first cell. And you can probably go down, and yeah, you can see every single cell. So that's nice. You can see that they're all very well balanced right now, which they should be. Okay, let's go and escape out of that. Down. Cell capacity. State of charge is 56.5%. That gives the full state of charge is the last time it was tested is 103.8. That was the last time it had a full charge. And right now the remaining is 58.6 amp hours. CC is 1. I'm not sure what that is. Maybe that's charge cycles. I bet that's charge cycles. So there's been 1 full charge cycle. Okay, let's escape out. Go back. Go back. We're going to go down. Yeah, that was the analog info. We'll go down and look at the BMS status. Enter. Status is idle. You can also look at the records, or let's look at the BMS status. Enter. Over temperature protection, over voltage protection, all those say no. Under voltage protection, over current protection, failures, no, and SCP, short circuit protection, no. So all those say no, that's good. Let's go and escape out of that. Parameter settings. Oh, non-production manufacturer cannot use. So we can't change any of the parameter settings. That's actually probably pretty good because the engineers that designed this battery, they're the ones that really should be changing those. And system settings. Baud rate 9600, and we will leave it like that unless our inverter wants us to change it. And I'm actually not sure if we change this or we change what the inverter says. So let's escape, see if we can go down, and that's it. So that's all the information on this screen. There's also a run light that's blinking saying that the unit is on. There's a light right here for alarm, and it's not lit, so that's a good thing. And we also have our state of charge, which is, you know, if we're guessing, it's going to be 25, 50, 75, 100. So we're right around between 50 and 75%. So that is perfect. Okay, let's go ahead and turn it off. And you turn it off just by pressing this button right here. I like this button because it's a nice metal button. It's not a plastic flip switch where you can accidentally hit it accidentally by just swiping your hand across. It's actually a button that you press. So that's nice, I like that. And also this battery is, I believe, serviceable. So we're going to go ahead and unscrew all these screws right here and take this lid off and take a look to see what's inside. All right, and then we have our connection to our display board right here that goes to the PCB. We got our positive and negative terminal connectors, and they are 6-gauge wire at 200 degrees. So that is very good. We also have all of our BMS leads right here, and they are all glued, which is nice. And so is the display board is glued also. Yeah, they're zip tied, and they have this plastic wrap going around everything. And then there is this big piece of metal right here that is protecting all the cells. So we'll go ahead, and it looks like we have 4 screws to take that off. So we'll go ahead and take that off next. All right, and there is all the cells. Underneath this metal thing, there's like this real thin foam to protect it from touching the cells. All right, and as you can see, this is made to be serviceable, so each cell is actually screwed on. I'm sure they're all screwed into a torque specification. You can see all of our temperature sensors, 1, 2, 3, and 4. They're taped down and glued, so I really don't want to pull one of those off. But everything looks really good. There's these bars right here that hold all the cells in place, and there's holes in them so you can, if there was an event where gas had to escape, they are all open. Man, I'm kind of confused about this configuration. Oh, because it goes across like this. It matches these, and then these two match up. This one here, and then here, and it goes across like this, all the way back to this negative, and then this negative goes back to the PCB. And actually, I don't know if I should be surprised or not, but there's only one 6-gauge cable. This 6-gauge cable goes, let's see, it's a bus bar between these two, and it's one 6-gauge cable that goes to the circuit breaker, and then it goes up to the first cell. And then it goes through the whole cells, and then there's one 6-gauge cable going back to the PCB, and then it goes through, what is that, the shunt right there? and then it comes out down there, and it goes to the negative connection right here. Here is all the communication ports right down here, and then here is the on-off button right here, which is nice. It's all metal.